Example 7. A ship travels 55 kilometers on a bearing of 27 degrees and then travels on a bearing of 117 degrees for 140 kilometers. Find the distance from the starting point to the ending point. Round to the nearest kilometer is needed. Bearing problem again. Have to draw a picture. Okay. So the first thing I'm going to do is draw the ship. The ship has to start somewhere. Okay. So I'm just going to pick the point right here. Okay. I'm going to label this as the starting point. Okay. And the ship is first going to travel for 55 kilometers on a bearing of 27 degrees. Okay, so we're going to start there. Okay, we're going to draw this in. Okay, again, what you have to do is draw north, south, east, and west. Okay, so here we go. Okay, so here's north, south. Okay, and I'm going to extend the north part because again, our bearing is being expressed by a single angle, so it's going to be relative to due north. Okay, so north, south, and then here comes my east-west line. Okay, so this is going to be west and east. Okay, so what we're going to draw here, and I'll put this in black. Okay, so we will start at the point right here, the starting point. Okay, we will align ourselves with due north, and we're going to rotate 27 degrees clockwise. Okay, so you're just going to have to eyeball it here. Okay, so the length of this line segment, okay, is going to be the distance traveled. Okay, so I want this to be 55 kilometers. Okay, I'm going to say we're just going to have to draw something, and that will represent 55 kilometers. Okay, actually, let me move this. Let's go ahead and mark the angle here. Remember, we rotated from north to here, and this is going to be 27 degrees. But the length of this line segment is going to represent 55 kilometers. The length of the line segments when you do these problems represents the distance traveled. Okay, so the ship is now here. Okay, it's traveled the 55 kilometers. Okay, and again, let me move this distance because it's going to get in the way once again. Okay, but I do need this distance on here. So I'll just put right here, this is 55 kilometers. Okay, so it's traveled the full 55 kilometers and now it's going to turn. It's going to start traveling on a new bearing, a bearing of 117 degrees, and it's going to stay there for 140 kilometers on that particular bearing. Okay, so at this point, okay, we have to draw another north, south, east, and west position here, another little cross. Okay, so here we go. So here's north and south, and then here will come east and west. Okay. All right, so here we go. So here is east and west. Okay, so we have to, and I will put this in black. Okay, so we have to align ourselves with due north. Okay, and we're going to rotate clockwise 117 degrees. Okay, so this is going to be 90 degrees once we align with due east. And then we're going to have to go a little bit past that. Okay, and we'll go ahead and say this is 117 degrees. The length of this segment has to represent 140 kilometers. Okay, that has to be way bigger than the 55 kilometer mark I drew initially. Okay, so it's pretty much maybe just under 3 times as long. Okay, again, you're going to have to eyeball it. Okay, we can't, when we're just doing a sketch, we cannot make things exact. Okay, all right, so at this point, okay, what we can say here is that this angle is 117 degrees. Okay, and the ship ends up here. So it traveled from this point right here in red, this point, to this point. Okay, and that is a distance of 140 kilometers. Okay, the question says we need to find the distance from the starting point to the ending point. Okay, this is the ending point. Okay, So we need to figure out this green length, the distance from the starting point to the ending point. Okay. All right, so this is a rough sketch of what's going on here. It is not exact, okay, but this is what we have to go on, okay? So we know, I will go ahead and highlight this to kind of color code it. We're trying to find the distance from the starting point to the ending point, which is going to be this segment right here. Okay, what we can do here is just start trying to decipher the information we've been given, and we can get a lot of information from the angles that we have seen in this sketch. All right, I am going to go to a very congested part of the picture. Okay, so right where I have the red cross, and I'm going to start looking at angles. Okay, so when I put my red cross in, I said this black angle is 117 degrees, but remember, when you put the north-south line and the west-east line together, they form a right angle. So if we take the 117 degrees and we subtract out 90 degrees, that's going to leave us with 27. That tells us, and I'm going to use a different color here because there's going to be a lot going on. This is going to tell us that this little angle right here, okay, is 27 degrees, okay? And like I said, I'm trying to figure out the little angles here, okay? So then what I'm going to do is I'm going to come down here. The next thing I see to do is down here, again, the north-south line and the east-west line form a right angle, okay? I know one of the angles that make up the right angle is 27 degrees, okay? So if I take 90 degrees and I take away 27 degrees, that is going to leave me with 63 degrees. That is going to tell me that this angle right here, right there, is 63 degrees, okay? So then what else can I do? Okay, well, I can, and this is very messy, there's a lot going on. I can extend this north-south line down, okay, so that I form a right triangle, okay? So this is going to be a 90-degree angle. This one's 63, so I can figure out this tiny angle right here, okay? So let me mark that. Okay, so I'm looking for this little guy right here. Okay, so we have 180 degrees in this triangle. Okay, we know one of the angles is 90, so that leaves us with 90 degrees. And then we know this orangish angle is 63 degrees. We need to take that out. That's going to leave us with 27 degrees. Okay, so that is this particular angle right here. Okay, this guy is 27. So this other 27 I have in black. Remember, let me reposition this. This is right here. Okay, that was this angle. 27 plus the 63 is going to give you 90. Okay, so this guy is 27. We can extend the east-west line here. Okay, so then we have a right triangle here. Okay, for this particular triangle, I see a right angle, a 27-degree angle. So now I can get this angle, and I'll put it in green just because we're getting a lot of colors here. So if I do 180 degrees minus 90, that leaves me 90 degrees. Take out the 27, that is going to give me, well, let me rewrite this. This is going to leave me with, hang on, if we take out the 90-degree angle, that's going to leave me with 90 degrees. I take out the little black angle, that's going to give me 27 degrees. Hold on. This stylus is just acting up. Give me a second. So we take the remaining 90 degrees. We take out the little black angle of 27 degrees. That's going to leave me with 63 degrees right here. Okay, so this is going to be 63 degrees. Okay. And then what this is going to allow now is now we can compute this angle. Okay. This east-west line is forming a straight angle, which is 180 degrees. Okay, so we have 180 degrees. Okay, we can take out from left to right the green angle of 63, the peach angle of 27, and then there's the angle we're trying to find, which is the double green marked one. And then we have an additional 27 degrees to take out. Okay, so if we compute this 180 minus 63 minus 27 minus 27, that last angle is also going to be 63 degrees. So I can mark this here. This is also 63 degrees. Okay, why in the world am I doing this? Okay, now that I have all these angles measured out, okay, I am going to look at my triangle. Okay, so here is my triangle. Okay, right here is where I'm focusing on. So let me just go ahead and color the whole thing in. Okay, so here's the triangle. I am focusing, and I am going to bring in yet another color. I am focusing on this particular angle right here, this purple angle, okay, in the triangle. It is comprised of a 27 degree angle and a 63 degree angle, okay? So 27 degrees plus 63 degrees, okay? If you add this up, you're going to get 90 degrees, okay? So really what's happening here is this is a 90 degree angle right here, okay? So let me kind of make this a little more apparent, okay? We had to do all of this work to show that this is a right angle. Okay, so this yellow triangle is a right triangle. And if we go straight across, this is the hypotenuse, and the hypotenuse is what we are solving for. We are trying to find the distance from the starting point to the ending point. This picture looks really complicated. So you may be wondering, how are we going to come up with the hypotenuse? Okay, because I don't know the measure of this angle right here. I don't know the full measure of this angle in the triangle. I know part of it is 63 degrees, but I'd have to add on this little smidgen, and I don't know how to calculate that, okay? But remember, all this work we did was to prove that this was a right triangle, and we know two of the sides. We know that this short side is 55 kilometers, the long side is 140 kilometers. We need the hypotenuse. That's the distance from the starting point to the ending point. So if we need the third side and it's a right triangle, all we have to do is use the Pythagorean theorem. Okay, so I'm going to write down c squared is equal to a squared plus b squared. We are solving for the hypotenuse, which is c. So let's go ahead and plug in. Okay, if we look at this, the a value is just one of the sides. Okay, I'll say it's 55. Okay, so this is going to be 55 squared plus b squared. That's going to be the other side, 140 squared. Okay, so we need to figure this value out. So we're going to go to our calculator. This is going to be 55 squared plus 140 squared. Okay, that's going to give us this gigantic number here. Okay, so 22,625. Okay, and so then if we want to solve for the hypotenuse itself, we just need to take the square root of both sides. Okay, we can only do the positive square root because the hypotenuse cannot be negative. Okay, and let's see what this turns out to be. Okay, if I take the square root of this answer, we are going to get this value. Okay, I will write the full decimal expansion for your notes. So this is going to be approximately 150.4160896. And now we can round. Okay, so let me put this as equals, since that's the full decimal expansion, and then I will round, and we need to round to the nearest kilometer. Okay, so if we look at this after the decimal point, there is a 4. Okay, so we don't need to bump it up. We can just go ahead and round. The nearest kilometer is 150. The units, this is a distance, it's going to be kilometers. Okay, so this is going to be the approximate distance between the starting point and the ending point. Okay, the key to working this problem was first doing the drawing, and then from the drawing recognizing that inside the major triangle here that there is a right angle.